Welcome students to our online chemistry class. We studied the topic halogen derivative. In that topic, now we have to learn about the representation of configuration of molecules. So for that purpose, can you recall some concept from 11th standard? Identify the type of following 3D representation of molecule 1 and 2 and state the significance of that lines. Can you remember? For that purpose, we go to our 11th standard and let us see what is this structure represent or formula represent. So, how to draw the molecules in 3 dimension? So, mainly there are different methods are there, but we follow Wedge formula and Fischer projection formula or cross formula. What is Wedge formula? First we'll see that one. In the Wedge formula, the molecule can be represented on plain paper by representing the single bond using different wedges or lines. This is solid wedge. Then this is the dash wedge and this is normal lines. So solid wedge used to represent bond projection, means bond going in upward direction from that plane towards the reader, and this dash wedge is used to represent bond going backward or below the paper and it goes away from the reader, and the normal lines indicated the bonds are in the plane of paper. So let us see one molecule and it is methane. The Wedge formula of methane. So these two hydrogens bonded in the plane of paper because they are shown with normal lines. Then this solid wedge represent bond going above the plane and this dash wedge represent bond going below the plane of paper. So this is the wedge formula and you have to observe from that bond which is going below the paper always. Now the one more formula is there and that is Fischer projection or cross formula. So in Fischer projection formula, the line can be drawn by visualizing the molecule with its main carbon chain, and always that carbon chain is represent vertically. So this is the important thing you have to keep in your mind. The carbon continuous longest chain is always placed vertically. The middle carbon, which is the cross section point, it is the carbon is not mentioned, and the groups on that carbon are mentioned at the end of that horizontal line. So the convention is that the horizontal line of the cross represented bond projecting up from the carbon. So here hydrogen and OH are up. That's why when we write the wedge formula of this Fischer projection, so they are shown with solid wedge. And vertical lines means COH and CH3 groups represent bond going below the carbon. So they are shown in wedge formula with dash wedge. So you can write your Fischer projection and wedge formula of the same compound. So these are the sign convention. While writing this formula, this compound is lactic acid. Its IUPAC name is 2-hydroxypropanoic acid, because there are two function group in this compound. One is OH, another is COH. So OH has least priority, COH has first priority. So we use suffix for COH and prefix for OH. That's why prefix is hydroxy and 3 carbon alkane is propane. Then E replaced by OIC acid. So in this way you can write the IUPAC name. Then one more compound is there. There are 4 carbon in that compound, and the second and third carbon is shown with star, means star indicate these carbons are asymmetric carbon. In previous case lactic acid also second carbon is asymmetric carbon, so it contains 4 different groups, so it is asymmetric carbon. Similarly in 2,3-dihydroxybutanoic acid second and third carbon is asymmetric. So first and fourth group, that is COH and CH3, they are behind the plane or below the plane, so they are shown with dash wedge, and the horizontal groups HOH on second and third carbon, they are on above the plane, so they is shown with solid wedge. So this is about the Fischer projection and cross wedge formula. So this is the, again we go to our main part, and that is the representation of configuration of molecules. So for that purpose, so I think all of you understood the Fischer projection or cross formula. Here we consider one carbon is attached to 4 different groups, and that carbon is chiral carbon. So it is shown with star. So this carbon is asymmetric carbon. Here also we write that carbon which is attached to 4 carbons, so it is also a star carbon. So these carbons are asymmetric carbon, they are attached to 4 different groups, and that carbon is chiral carbon. Here chlorine and hydrogen, they are below the planes, and H and PR groups shown with bonds that are above the plane. Now when a tetrahedral carbon is imagined to be represented in the plane of paper, all the 4 bonds at this carbon cannot lie in the same plane, and the bonds are shown with simple lines. They are in the plane, so Br and Cl are in the plane. Iodine shown with dotted wedge, so they are below the plane, and hydrogen shown with solid wedge, so it is above the plane. This is according to sign convention. Now you have to draw the structure of enantiomers of lactic acid by using Fischer projection. So you can try at home. Then you can also draw the structure of enantiomers of 2-bromobutane using Wedge formula. So try this at home. This is your practice session.